We've got a rainwater harvesting system, and this is the pump controller from that system. And about 6 months ago we started getting problems with it. It was just a red light comes on, a fault light, and it's that LED there, the red one. I reset it and everything was fine until about a month ago when it happened again, and then it just carried on getting the fault more and more frequently. So eventually I took it apart, got this circuit board out, and checking on the internet, the only problem I could see, there was a well-known problem with it, was that if it's operated more than 25 times a minute, then the filter capacitor can go. Now there's electrolytics in here, so I thought maybe it's the filter capacitor for the supply. So I took those out and tested them, and they were fine, so there was no problem with those. Then I looked at the yellow capacitor here that's used in the dropper circuit to power the circuit, and I measured that. It's here. It should be 1 microfarad, but I'll put it on the tester now and we'll have a look at that. That is 288.6 nanofarads with an ESR of 3.5 ohms, so that's not right, to put it mildly. So I had a look around in the parts bin, and I managed to find a 950 nanofarad capacitor, which is in there at the moment, but it's a really old one. I'm not really very happy leaving that in there, so I've bought some more. I tried to get the best quality ones I could find, so I got one Vert and one Chemet. Now the Vert ones I'm a little bit averse to, because they were the ones that had failed in the induction hob that I recently fixed. So I think I'm going to go with the Chemet. I've got quite a few of these, so if it happens again and the capacitor goes, then I've got plenty of spares. So I'm going to take this out and put that in. So previously I took the two halves apart, but that was some very tricky soldering here on some metal contacts that come down with the supply, so I don't really want to do that. So I'm just going to take the capacitor out here. Just going to heat that up, move that out a bit. I might have a go at cleaning out the contacts. That worked fairly well last time. There we go. So one interesting thing that I found with this circuit was that it's not actually got a microcontroller on it. It's actually just a 4093, which from memory is a counter timer circuit. I might have to look that up. So I think this is just a simple delay. It doesn't actually do anything very complicated. Now that's a bit odd, because I don't really know what the fault line does. I'm going to get a solder sucker. I had to go with desoldering whip. The pads are quite agricultural on this, so it took a bit of persuading to come out. I tried the solder. See if I can put this in some sort of clamp. Never have enough hands when we're doing this sort of thing. So I think this is an older version of the pump controller as well, so these circuit boards aren't obtainable anymore. I did find some companies on the continent that sell them, but it doesn't really matter with something like this, because these components are totally standard. There's no firmware on there, nothing proprietary, so the whole thing could be re-engineered if need be. It does have some interesting reed relays on the back here. I think that's used to sense a diaphragm, which is used to detect the water pressure. That's my guess. Perfect. So that's the way to do those holes. There's not a lot of copper on these. That was a fail. When I was trying to take the mains connections off, that was really bad because there was so much copper there. Just took forever trying to heat the pads up. So that's popped out of there nicely. Just take away some of the copper. Sorry, some of the solder that I've splattered around there. So I'm going to go with one of these grey Chemets. See what they do, see how well they last. So this is using a dropper capacitor. There's a resistor here as well, so that's used to drop the main supply down to whatever power supply they've got in here. And I'll just bend the leads out there a little bit, stop it falling out when I turn it upside down. So because it's essentially across the main supply, I've put an X2 class capacitor back in, which is what was in there originally. And that's just a capacitor that's designed to sit across the mains. I also put a 310 volt one in instead of a 280 volt one that was in there before. That's not going to make much difference. There we go. Nice shiny new one instead of a slightly suspect old one, although that's seemed to have worked, so don't want to be too nasty to it, and I'll put it back in the box and it can help me out at some other point. Let's just cut those leads off. There we go. Right, I'll put that back into the rainwater harvesting. So for anyone else who's got one of these and having the same problem, it does appear that that capacitor is a little bit of a weak spot. So I'll update later on after a few months and see how well the fix went.